Welcome back to Scripps Tech. I'm Phil Torres. Now to the story of a man who was paralyzed in a tragic accident. Unable to move his limbs, he didn't give up hope. He could still imagine throwing a ball or driving a car. And now a team of researchers is trying to harness that very brain power to help him move again. Scripps Tech's Crystal Dilworth is a neuroscientist. She's going to explain how this works. Hey, Crystal.
On mornings when 50-year-old James Johnson arrives at the Casa Colina Research Institute in Pomona, California, he's here to do his part to forward scientific knowledge. He's a deep thinker whose thoughts are changing what scientists are learning about the brain-computer interface, or BCI, the ability of the human mind to connect to and control a machine like a computer. Embedded in his skull are two pedestals, both connected to an array of fine wires that were surgically implanted into specific regions of his brain 5 years ago. To appreciate the amazing research being studied in this lab, you first have to get to know this amazing man who is a true science pioneer. From his teen years on, all he wanted to do was to help others.
But all the while, I was always giving back, and that's kind of the makeup of my life story.
He married and raised a family. Life was good until that fateful day.
I'm driving my go-kart, and I hit an object in the road, and it caused me to crash into a curb and the go-kart to flip. And I ended up landing on my head, which subsequently broke my neck. And now I'm paralyzed.
Post-accident, how did you handle needing help instead of being the one that was giving the help?
It was devastating. It was really hard because who would have thought I would be paralyzed and, now I can't do, the things that I was doing before. And then I realized at some point that I could still do more. And I especially realized that after I was introduced to this whole project.
Dr. Charles Liu is a neurosurgeon who specializes in this type of brain surgery.
What is the benefit of implanting an electrode into a human brain?
The reasons are, on the one hand, to learn more about how the brain functions. We know very little about the brain in spite of all of the research that's been done over the course of the last 50 years. On a practical level, we want to understand why things don't work right.
The search for these answers continues here in the lab, where for the last 5 years, James has worked with a team of researchers, including Kelly Kadlick and Jorge Gomez.
This is the head stage that we connect to the pedestal that is in his skull. These are the tiny little pins that make contact with the pads on the pedestal, that connect to the array. And you can see that we just essentially plug him in, sort of like an outlet, and then I screw it in to secure.
Once connected, Jorge monitors the brain activity. Then, James is asked to perform some specific tasks to calibrate the system. On the screen is a map illustrating how the neurons in his brain are responding to his thoughts.
James, could you imagine closing your hand, please? And now relax.
As James imagines closing his hand, the red areas of the map show the strong activity of neuronal signals coming from his brain. The blue areas mean less activity. And here, James is imagining pitching a baseball during a game.
So here I'm picking up my arm with the ball in my hand, winding back, and then letting the ball go. And then my arm back down to the side.
Oh, wow. I can see all those parts of movement.
That's what it visually looks like when I'm thinking about any particular movement.
What is it like to see your thoughts on the screen?
It's actually pretty amazing because being paralyzed, obviously you don't see a result when you attempt to move things.
The brain-computer interface study continues with a series of exercises moving a cursor around a target. At first, with computer assistance to calibrate a piece of equipment called a decoder. James is observing the cursor moving around the target. While he does, the decoder records the neuron activities from his brain. The next task involves James imagining he's moving his right thumb as he would with a video game controller. Here, the computer is assisting his cursor movements and is also recording his brain activity. Next, with only the power of his mind, James completely controls the cursor movement around the screen, aiming for specific targets.
What do you think?
Yeah, that was the best one, yeah.
And finally, he finishes up with fast movements on a complicated grid.
How does it feel, James?
Yeah, we're good. We can drive.
Coming up, James's dream of driving with the power of his mind comes one step closer as Scripps Tech continues. Scripps Tech's Crystal Dilworth picks up our story with a journey that began on a computer screen, but one day could end up behind the wheel of a car.
50-year-old James Johnson, who was paralyzed in an accident 8 years ago, is controlling a computer with his mind. After a series of tasks moving a cursor around on the screen using only his thoughts, he's ready to drive a simulated car on a virtual city street.
So the blue circle, when it goes right, I turn the vehicle towards the right, and left to the left.
What are you imagining moving? Is that your hand?
I'm imagining my hand turning the wheel to the right or to the left.
You're really visualizing a wheel.
Right. You guys ready?
Yeah, let's see it in action.
The tricky part is keeping the circle in the middle, because remember all those neurons that are firing all over the place, it can cause me to jut out in a direction I don't intend to.
James says that the simulation he's working on with the research team is a test bed for future autonomous automotive technologies. He's also testing tools like a robotic arm that reaches and grasps items via his thoughts. This brain-computer interface technology is inspiring the creation of future software and hardware to assist those with special needs.
What have we been able to evolve from the lab to the clinic? And, is there any new technology that we're now able to apply to patients generally that we wouldn't have if we hadn't done these types of experiments?
The brain is extremely complicated and very difficult to understand. So a huge amount of work has to be done in just a scientific realm before you can imagine, how this information can be used to create a useful tool. Right now, we are, I think, on the precipice of having enough scientific evidence and body of knowledge that the useful tools can be really considered.
I think that this technology has enabled me to become more human again.
The idea that technology can make us feel more human may surprise many, but not people like James Johnson. His contribution to the study of neuroscience is already benefiting humanity in the most thought-provoking way.